Now that you know what energy is, we're going to talk about something called work. The definition of work is simple. It's how much energy an object loses or gains when there's a force applied on it. So the formula for it is simply work equals the change in energy, and it's equal to the force applied on it times the distance over which you apply that force. So as kind of a real world example of this, so you can see things. If let's say that you have a job and you're working for your boss, and it's just you and your boss in the building right now, and your boss has $500 in his pocket, and you've only got 25, you're kind of struggling a little bit, and you got to do some work to get paid. Between the two of you at the beginning of the week, you have $525. So let's say some time goes by, and later on we take another photograph of the two of you, and now your boss only has $400, but you have $125, so you're looking a little bit better. But the total amount of money still hasn't changed. The money that existed here is the same as the money that existed over here. What's different is that some of the money was transferred. Some of the money that your boss had went to you. In fact, the amount of money that got transferred was $100, right? So we would say the amount of work that you did was you made $100. It's not like that money came out of nowhere. It came from your boss. There was an exchange. Your boss lost 100 and you gained 100. And with money, we call that work. But with physics and with energy, it's the exact same thing. You can have energy get exchanged between objects. And in physics, we call that exchange work. So as a really basic problem, we've got how much work does it take to carry a 6 kilogram rock up a 5 meter ladder? So if I track all the energy at the beginning of the problem, the rock doesn't have any because it's just sitting on the ground and it's not moving and it's not compressing a spring. So the rock begins with no energy, but once you carry it up to the top, it gains energy. So if I work this thing out, to figure out the amount of gravitational energy that it has, that's just mass times 10 times height, so that's 6 times 10 times 5, and the rock now has 300 joules of gravitational energy. And it's not moving at the top, and there's no spring involved, so I just kind of left this stuff out. I wrote it for you, but we didn't really need it. But check it out. The rock started with 0 energy and ended with 300 energy. Sort of like this worker over here. He started with $25 and ended with $125. So he got $100 richer. This rock gained 300 joules of energy. And since I said over here that work is the change in energy, we would say that the amount of work done to the rock was 300 joules. So we would say W equals 300 joules, since it's the change in energy. But what about the fact that I said that work is also equal to force times distance? Could we have calculated it with that formula? Let's give it a try. Well, for the amount of force that it would take to lift that rock, the force is simply 60 newtons because the only thing you have to fight is gravity. And if you give it an upward force of 60, then you can carry it up at a slow velocity using that much force. So the force is 60 and the distance over which you use that force is 5 and you get 300 joules of energy. In fact, I kind of cheated and went backwards. It turns out work is the fundamental idea here. The only reason this formula is true is because mg is the force and h is the distance over which you apply that force. And in fact, with a little calculus, I can prove the other energy formulas as well. I'll probably do that in a later video. And by the way, didn't I say before that the one thing you have to know about energy is that the total at the start equals the total at the end? So what's up with this? Why is it changing? Where did those 300 joules of energy come from? Well, they came from your body. Just because I didn't include your body's energy in this table doesn't mean that it wasn't there. Your body had to give up some of its energy in order to carry that rock up the ladder. So your body lost 300 of joules of energy in the process. And that energy came from your food. And your food's energy came from the sun. And we won't go beyond where the sun's energy comes from. We have to wait a lot of videos for that. But the main idea is energy is still conserved. It's just work is a description of how that energy moves around from one object to another.